Hi students, how are you all? This is Swapna, Mathematics faculty from EduHunt IIT and NEET Academy. I hope everybody are doing well, right? So do you remember what we have discussed in the last session? Yes, we have discussed about section formulas, midpoint formula, internally and externally points, centroid, right, distance formula, all these things which we have already seen. Similarly, area of triangle, very good, right? All these things we have discussed about the topics in coordinate geometry, right? In today's session, we are going to learn about a new concept, concept number 5 from your worksheet, which is about slope and inclination. Fine. So what is slope and what is inclination? We are going to find about the concept of slope and inclination in today's session. Let's begin. Chalo? Yes. Here comes the first definition, inclination of the line. So how do you define an inclination? The angle made by the line with the positive direction of x-axis. So basically the angle is formed between any two lines, correct? So for suppose if I take a coordinate geometry like this, okay? So how do you define an inclination? So for suppose if I take a line with respective to positive x-axis, with respective to positive x-axis. What is a line I have taken here with respect to positive x-axis? This is my line. Is it visible? And this particular angle is making with a theta. Let me take this as a theta with respect to positive x-axis, and this particular theta is called inclination of the line. How do you define? Inclination of the line. Any line if you take, okay, that particular line, any angle, then you will make an angle. If that angle makes a direction with a positive x-axis, then such type of angles are called inclinations. Okay, inclinations. So here this particular angle theta is making with the positive direction of x-axis. Clear with this? Chalo. So my next definition is, if theta is the inclination of the line, then 0 less than or equal to theta less than 180 degree. What is my next point? See here. What is my next point? For suppose if you are taking an theta is an inclination, then what should be the range of inclination? It should be 0 less than or equal to theta. That means my particular inclination must be greater than 0 or equal to 0. It can become, see, if it is making a 0 angle with a positive x-axis, of course it can become, so theta should be greater than 0 or theta is equal to 0, and theta also can be less than 180. See, up to this it can become, up to this, right, 179.555. Theta can become less than 180 but not equal to 180. If it is exactly equivalent to 180, then that particular angle makes an with respective to negative direction of x-axis. So that is the reason I am telling you theta should not be equal to negative direction of x-axis, correct? So what is the range of inclination? 0 less than or equal to theta and less than equal to 180 degree. So I repeat again, how do you define an inclination? Inclination is nothing but the angle made by the positive direction of x-axis. Very simple. So what is the range of inclination? Theta must be less than or equal to 0 or less than 180 degree. Bas, khatam. Clear with the inclination points? Right, chalo. Next definition what we are going to learn? What is my next definition? We are going to learn about slope of a line. What is the thing we are going to learn? We are going to learn about slope of a line. If theta is the inclination of the line, let me read out about the slope. If theta is the inclination of the line, then the value of tan theta is equals to slope of the line. So what I am telling you, for suppose here you are taking a line, just a minute, line which makes an angle theta with reference to positive x-axis. This particular theta is called inclination. This particular theta is called inclination. Right. Now, how I am defining about a slope? The tan theta of inclination. So, for suppose if you are taking this is a inclination. So, let me drop a perpendicular line of this inclination. Okay, between these two lines, this is making a 90 degree. Right. And let me address, this is my 2D geometry. So, let me locate some point in terms of x and y. Then what does it means? It is, let me take it is x axis and let me take it is y axis. Obviously, right? The horizontal distance is x axis and the vertical distance is y axis. Already I have told you, right? Addressing about a point. So, tan theta is nothing but slope. Slope is defined as the tan theta of inclination. The tan theta of inclination is called as slope. The tan theta of inclination is called as slope. So, what is the tan theta of this particular line? If I address the point as x comma y, the tan theta will become y by x. So, this y by x will become slope of my particular thing. Fine. Basically, how you represent slope? What is the denotion of slope? Slope is always denoted by the small letter m. Okay, m is equals to tan theta. So, this is what you represent about slope. Am I clear? So, how do you define a slope? The tan theta of inclination is defined as a slope. Clear with the point? Yes? So, read out the definition. If theta is the inclination of the line, of course, then the value of tan theta is defined as slope of the line. That is what I just tell you, right? It is denoted by which letter? Small m. It is denoted by which letter? Small m. And that is m is equals to tan theta. This is what I told you, right? Yes. Next. For example, in your real-time application, where you are seeing this slope. For example, in parks and grounds, whenever you visit any park, you will have a sliding czar, right? Have you ever visited such type of sliding czars? Yes, you will slide. Many children like to play, right? So, in the sliding czar, what you will be doing? You will slide. Of course, right? Let me take, if this is a ground, if this is a whole ground, okay, and you will have like this, some particular, for example, if this is a ground and this is a ground level part, okay, let me take one sliding czar like this. So, what you will be doing? You will go and this is the steps, you will slide from here, yes or no? Just imagine yourself, you will slide from here. So, this is making an angle with respect to positive x-axis only, correct? X-axis only, right? So, this particular theta, what is the theta here? 90 degree, yes or no? So, slope of, so exactly if you stand here, for suppose, imagine if you are here, imagine if you are at the steps, can you able to slide? No, right? Can you able to slide? No, obviously no, right? You can slide only when you are sitting on the sliding czar. Am I correct? So, exactly when you are exactly on the steps, that means, for suppose if you are standing exactly on the vertical line, that means on the y-axis, can you able to slide? No, you will exactly fall down, right? You will exactly fall down. That means slope will not be there. Yes or no? Slope of y-axis is tan 90 is how much? Already we have learnt in trigonometry, tan 90 is undefined. Correct. Excellent. So, whenever you are on vertical, exactly on y-axis, exactly on 90 degree, you will fall down. You will not have any kind of slope. So, tan 90 is undefined. Correct. Next. So, exactly if you are sitting here, for suppose you slided from on the sliding czar and right now you are here. See, I am representing here your on the base of the sliding sir. On the base of sliding sir. Can you able to slide here? Of course no. Of course no. So you are making an angle is 0 degree with a positive x-axis. Right. So what is tan 0? Tan 0 is 0. Why I am taking tan here? Because slope is always defined as tan theta, which just now I have explained you. Right? Just now I told you that slope m is always defined as tan theta. Whenever you are on horizontal x-axis, tan 0 is always takes 0. Correct? Just imagine the example of sliding sir, that is a real-time application. Right? So tan 0 is 0, tan 90 is undefined. Right? Yeah. So that is what we are going to learn. So first point, slope of x-axis. Whenever you are on the base of sliding sir, what is your slope? It's 0. That is what? Base of x-axis means, in mathematical terms I am telling you, x-axis. Slope of x-axis is what? It is 0. Right? Similarly, slope of y-axis is not defined. On vertical axis, can you able to define a slope? No. Slope of y-axis is not defined. Correct. Next, slope of horizontal line. Of course, the other name of x-axis is horizontal line. If in the question, can you see, like if in the question you are saying like horizontal line like that, in that case also slope of horizontal line is always treated as 0. Right? And slope of y-axis can be treated as vertical line. What is the slope of vertical line? Is not defined. That is what I am telling you, right? See, read the 4 points about the slope. What I am telling you, slope of x-axis or horizontal axis is always 0. Slope of y-axis or vertical axis is always not defined. Am I clear with the point? Yeah. Next point about the slope is slope of the line passing through 2 points ax1 y1 and bx2 y2 is what? ax1 y1 and bx2 y2 is what? First, suppose if you are having a line, of course, because in order to exist a slope, first you need to have inclination. Inclination forms only if forming a line with a positive x-axis. Am I correct? Avuna kada? Mundu inclination, slope undali ante inclination undali. Avuna kada? Inclination eppudu untundi? ఒక లైన్ విత్ రెఫరెన్స్ టు పాజిటివ్ x-axis తీసుకుంటే ఈ రెండు లైన్స్ మధ్య మీకు యాంగిల్ ఫామ్ అవుతుంది. Am I clear? So the inclination is making with a positive x-axis. The angle is making with a positive x-axis. That thing is called inclination. The tan theta of inclination is nothing but slope. Correct? I told you many properties about the slope. Just now we read. Now my particular question is, ఒకవేళ ఈ లైన్, whatever the line you are considering, for suppose many points will exist on the line, right? If it is line segment, you will have finite and ending points, but you don't have finite number of points on the line. Line is undefined, right? You will have only starting whenever you, I guess you are familiar with line segment and line. Line segment ante enti? If you have starting point and ending point, that will be fixed. That is called as a line segment, right? But whereas if you take about line, you don't have ending points on both the ends, right? So take a line, you'll have a many number of points on the line. Let me take only 2 points of the line for our convenience. What are the 2 points? A x1 y1 and b x2 y2. Then how do you define a slope? How do you define a slope? Let me check here, just a minute. I'll represent with a diagram. Take, this is x-axis and this is y-axis. So what I am telling you here, take any line, inclination which is theta, theta, this is my theta and this is my inclination. So I have to consider 2 points here. Let me take what are the 2 points, A x1 comma y1 and B x2 comma y2 on the line. Okay, so then how do you define x1 y1? What is x1 here actually? x1 is nothing but the distance from origin at x1 units on the x-axis. Correct? x1 అంటే ఏంటి? ఆరిజిన్ నుంచి x1 units distance లో x-axis మీద ఉంది. This is what you will define about x1. అంతే కదా, already I told you, right? x1, let me address this. This is x1 and this is y1. Vertical distance is y1. Similarly, draw for this also. This is from here to here. This is x2 and from here to here, what is this? This is y2, y1, y2, x1, x2, right? So what I need to find out here, I need to exactly found the slope existing between two different points on the line, and it is, of course, slope is defined as tan theta of a line, right? So first what I am doing, draw a line, some AC, let me take this is 0, P. Draw a line, some AC. How you need to draw this line? Which should be parallel to OP. That means you need to construct such type of line that is parallel to x-axis. So this is x-axis, and what is a parallel to x-axis? Let me take this is a parallel line. So this is a parallel line and this point is called C. This point is called C, right? Just a minute. This point is called C. Yeah. Now please observe, AC and OP are parallel lines. Am I correct? I have constructed in such a way, AC and OP are parallel lines. Can you imagine from the figure? Yes, right. Then what must be this AB line will act like? This is AB, right? If two lines are parallel, and this line will act like what? I am expecting answer from you. This line, excellent. This line will become like transversal. Do you remember? This line is called transversal. If you are drawing any two such lines, parallel lines, and the other line which is intersecting the two parallel lines, such type of line is called transversal line. So here this is my transversal, correct? This is my transversal. So in transversal, if this is theta, so according to the transversal, the corresponding angles, this also becomes theta, correct? This also becomes theta, yes or no? So just draw the figure. What I am having here, A, C, B, correct? And this is my angle theta here. So slope I need to find out here. Slope M is equals to tan theta, correct? And how do you define a tan theta? Opposite side by adjacent side. You should not forget. How do you define a tan theta? Opposite side by adjacent side. So what is opposite side here? BC. What is adjacent side? AC. So that means I need to find the values of BC and AC over here, right? Yes or no? So what is BC value from the diagram where you actually found? This is the BC, correct? This is the BC. So let me take, if the distance from here to here is y2, can you see from the figure? ఇక్కడ నుంచి ఇక్కడికి y2 ఉంది and the distance from here to here is y1, here to here is y2 and this distance is y1. What must be the distance? Remove that, y2 minus y1, correct? Total minus subtract y1 part. So this becomes y2 minus y1. Am I clear? Similarly, on the horizontal line from here to here it is x1, x2, from here to here it is x1. So what this becomes? x2 minus x1, x2 minus x1, correct? So this is becoming x2 minus x1 and this is becoming y2 minus y1. Am I clear? y2 minus y1. So from the figure I just substitute the both values here. What did I got? BC is y2 minus y1 upon x2 minus x1, correct? y2 minus y1 upon x2 minus x1. Please have a glance of the problem, whatever I derivated it. Please. With the concept of parallel lines, then I have drawn a transversal. So if you have a transversal, I made both the angles are equal, which is equal to theta, and theta is nothing but slope, inclination is theta is equal to inclination. The tan theta of inclination is defined as slope. I have derivated and finally I got an answer, y2 minus y1 divided by x2 minus x1. Am I correct? Please look into it. Understood? So let's read out the next point about the slope. Just now I have derivated. If you have 2 points on the line and you need to find the slope of a line, then how do you define a slope? It is y2 minus y1 divided by x2 minus x1, which can also be represented as difference of y coordinates to the difference of x coordinates, right? y2 minus y1, those both are representing a y coordinates of course, right? So that was about finding a slope whenever you have 2 different points, right? Now what is my next point? What is my next point? Slope of non-vertical lines. Non-vertical lines. Ax plus by plus c. For suppose if you have a line called ax plus by plus c, then slope can also be equal to m is equal to minus a by b. M is equal to minus a by b. Am I clear? That means coefficient of x. So what is there? Coefficient of x is what here? It's a. So this is minus of coefficient of x, which is minus a, divided by coefficient of y. What is coefficient of y here? B, of course. So minus a by b. Where you need to apply this formula in the slope? Whenever if you have a line ax plus by plus c, directly you can find it out, the slope, by taking minus coefficient of x divided by coefficient of y. Here it is a by b. So next one. Fine. Let's see one example so that you can apply it wherever you need it. Okay, you'll have some clarity regarding this. Example, what is given? Slope of the line passing through the 2 points. Of course, there are 2 points. What are the 2 points? 1, 2 and 3, 4. 1, 2 and 3, 4. Here I am having 2 points 1, 2 and 3, 4. 3, 4. So just now I told you about the derivation. Slope of 2 points x1, y1 and x2, y2, right? x2, y2, how you have defined is equal to y2 minus y1 by x2 minus x1. x2 minus x1. So let me address these both points here. First one is x1, y1 and second one is x2, y2. Okay. So let's substitute in the formula. So what is y2 here? 4. What is y1 here? 2 divided by what is x2 here? 3. What is x1 here? 1. 4 minus 2 is 2. 3 minus 1 is also equal to 2. 2 by 2, answer is equal to 1. Of course. So what is the slope here? It's 1. It's 1. But you have to express in terms of tan, right? Where tan 1, where 1 you will get in terms of tan? Very good. Excuse me. Very good. It will get in the form of tan 45 degree is equals to 1. Tan 45 degree is equals to 1. Understood? Chalo. I hope everybody clear with this example. Next, two more note points about the slope. So what are the two more note points? If M1 is equal to N2, then the lines are parallel. Means what I mean to say, if you have, of course, if you have, for example, draw a coordinate axis. If you draw the line which is parallel to x-axis or horizontal axis, let me take this is M1, this is M2. Here also the slope value is 0, or here also the slope value is 0. From the real example only you can find it out, right? Yes, of course. So that means what I am going to say, whenever you have considered any two parallel lines, always that slopes will be equal. Let me check if, for suppose, if two lines are perpendicular, let me draw perpendicular lines. This is x-axis and let me take a first line L1 which is making an inclination theta 1. So I need to take such a line which is perpendicular to this line. So can I draw like this? See. So this is my L2, okay, and this is my theta 2. Correct. This is my theta 1. So theta 2 represents an inclination of second line, correct? So let me write slope of line, first line L1 is equal to M1 is equal to tan theta 1. Okay, this is tan theta 1. So that means if I draw like this, okay, so this is equal to tan theta 1. Correct? Yes or no? Similarly, slope of second line, what I have taken? Slope of line L2 is equal to M2 is equal to tan theta 2. Correct? So what I am having here? Theta 2 represents here an exterior angle. Can you see here? Where does theta 2 represents here? An exterior angle. So how do you define an exterior angle theorem? Anybody knows about exterior angle? Theta 2 here is exterior angle, correct? Exterior, what is exterior angle property? You might have learned in your junior classes. Exterior angle property is defined as an exterior angle is equals to sum of two interior angles. An exterior angle is equal to sum of two interior angles. So what is an exterior angle here? Which is theta 2, correct? What are two interior angles here? Theta, sum of two opposite interior angles, right? What is exterior angle property? This you will learn in the lines and angles chapter from your childhood, okay? In the 7th class you might have got this. Lines and angles mein exterior angle property you will be having. So how do you define exterior angle property? An exterior angle is equal to sum of two opposite interior angles. Did you understand? So what I am doing here, theta 2 is an exterior angle here, right? So what are two opposite interior angles? One is theta 1 and these both lines intersect at 90 degree, of course. So theta 2 is equal to theta 1 plus 90 degree. Did you understand how I have wrote? An exterior angle is equal to sum of opposite two interior angles. Got it? Am I clear? Yeah. Now apply tan theta on both sides. Applying tan on both sides. Tan theta 2 is equal to tan of theta plus 90 degree. Correct? So which is tan theta 2 is equals to tan 90 plus theta is minus cot theta. Minus cot theta. So tan theta 2 is equals to cot. How can I define? It is a reciprocal function of tan. Correct? You have learnt in trigonometry. 1 by tan theta 1. Yes or no? Transform this tan theta 1 to that side. What it will become? It will become product tan theta 1 into tan theta 2 is equals to minus 1. How do you define tan theta? Tan is nothing but slope. Slope is represented with m. So this is m1 which represents slope of first line. Already I have written there. See, m1 into m2 is equals to minus 1. So that is what I am telling you. This is a derivation part. If two lines are perpendicular lines, then we can derive that m1 into m2 is equals to minus 1. The product of their slopes is always equal to minus 1 if two lines are perpendicular lines. If two lines are parallel lines, you don't have any problem with it. Always the slopes will be equal. Agar दो lines parallel है, always the slopes will be equal. If two lines are perpendicular, product of their slopes is always equal to minus 1. Bas, khatam. Understood? Anybody having doubts or queries related to this topic? You please tell me out in the comment section. Clear? Chalo. So this was about the slope. Okay, this was about the slope and inclination of today's concept class. So let me recall you about the slope and inclination of today's class once again. So what is inclination? Inclination is defined as the angle made by the positive x-axis. Simple. And what is the range of inclination? That must be greater than or equal to 0 or less than 180 degree. Bus. Next, come back to the slope concept. How do you define a slope? The tan theta of inclination, right? The inclination tan theta is defined as slope of that particular line. And I told you many points regarding a slope. If you are taking a slope of x-axis or horizontal axis, it is always making a 0 degree. Second point, slope of y-axis or vertical line, vertical axis, which is y-axis. Always the slope of such particular line, which is in the tan 90, is not defined, right? Next, if you are taking any 2 points, a x1 y1 and b x2 y2, then how do you define a slope? Slope m is nothing but y2 minus y1 divided by x2 minus x1, right? Next one, slope of line ax plus by plus c is equals to 0 is minus a by b, right? This is the fourth point about the slope. And if two lines are parallel, their slopes always equal. And if two lines are perpendicular, their slopes, the product of their slopes gives minus 1. This was about the slope. I hope everybody enjoyed the session. Thank you all. And I am telling you, even though if you are thorough with the concept, maths will be perfectly, you can get the perfect fruitful result whenever if you are very much confident in the problems part. So for practice, I request you to go through worksheet problems and then come back to me, right? In our next session, we are going to discuss about worksheet 5 of coordinate geometry. Thank you all. Bye-bye.